The sense of differentiation is like that. We are trying to find the gradient of a line, okay? Either be a line on the curve. That is why there's a need for differentiation, okay? A gradient of a line on the curve. Now let's look at something. Assuming I'm having y to be equals to 2x plus 2, okay? Now, you know that you and I know that this is a line, okay? Now, if I want to find the gradient of this line, we know that every line can be drawn on the Cartesian plane, and on the Cartesian plane, the most prominent feature on the Cartesian plane is the origin, which is 0, 0, okay? So once I'm at the origin, all the axes will be equal to 0. So let me say I'm at the origin at y, the axis of x should be 0, okay? So this, if I input it in the line, I'll get y to be equal to what? 2, okay? You can input it. If you input 0 here, 2 times x, 2 times 0, you get what? 0. Okay, so y will be 2. So the coordinates you get here, you get 0 and 2, okay? Now, on the same axis, when I am working on the x-axis, so I can say at x, my y2 will be what? 0. So if I put y here 0, my x will be equal to what? Negative 1, okay? My x will be equal to negative 1, okay? Now, I've gotten my second coordinate to be negative 1 and 0, okay? Now, let me name these coordinates to be coordinate A and coordinate B, right? And I am trying to find the gradient between coordinate A and B because these two coordinates basically forms a line, okay? Now, we say the gradient of every line is equal to change in the y-axis all over change in s coordinate, okay? Which will be equal to y2 minus y1 all over x2 minus x1, right? Now, we can name these coordinates. Let me name here x1, y1, x2, and y2, okay? So you can input the coordinates inside this factor. My y2 is what? 0 minus y1 is what? 2, okay? All over. My x2 is what? Negative 1 minus x1 is what? 0. So this will be equals to 0 minus 2 will give me negative 2. Negative 1 minus 0 will give us negative 1. And this will be equals to what? 2, okay? So now, we know that the gradient of this line is equals to 2, right? So the fact that the differentiation has come in place. Let's look at something. In differentiation, we use two functions, okay, or rules. We have what we call the Leibniz notation, okay? Leibniz. This yesterday I said the Leibniz notation and functional notation, okay? Leibniz notation and functional notation, okay? So now, with the Leibniz notation, it's just a scientist, a great and a famous scientist. If I have this function like y is equal to 2x plus 2, then if I want to differentiate it, as you use dy over dx, okay, it is being written as dy over dx, dy slash dx. And with the functional notation, you know very well that this function can still be written as f of x because the expression within the function is in terms of x, okay? So with a functional notation, when you are going to differentiate it, you can write it as f prime of x, okay? And it's the same thing. But throughout our lesson, I'll be using the Leibniz notation. But in one way or the other, I'll be fixing the functional notation inside. So now let's come. Differentiation states that if I have a function like y is equals to ax to the power n, and I want to differentiate this function, let me use the Leibniz notation. I have my dy, I'll get my dy all over dx to be equals to, now, the rule says that, first of all, you drop the power of x, okay? So now let me drop it. I'll get my n, and you multiply it by the coefficient of the x, a, and you write your x back, Now write the power back and subtract 1 from the power. Okay? I said the first thing you do is that you drop the power, multiply it by the same function, then you write your power back and subtract 1 from the power. Okay? So for example, if I have x to the power 3, okay, the coefficient of this x is what? 1. Okay? So my dy all over dx will be equals to, I'll drop this power 3, okay, multiply it by the function x, okay, and now raise the power 3, and then do what? You subtract 1 from it. Okay, so this will be equals to 3x to the power 2. Okay, and this is the derivative of this function. Okay, now let's come back to the fact that we want to find the derivative of this line y is equals to 2x plus 2. Okay, it means that my dy over dx of this of y is equals to 2x plus 2 will be equals to, first of all, the power to this x is what? 1. You drop the power, so 1 times 2. This is EMA, so you will not be writing it that way. X to the power, the 1 here, so 1, and you subtract 1 from it. Okay? And the rules also states that anytime that you are differentiating a constant, it should be equal to 0. There is a reason to that. So plus 0. This is a constant, so 0. Okay? So this will be equal to 2x to the power 0. Any number to the power 0 is 1, so you get 2. Okay? 2 times 1 will give us 2. So now let's compare. The derivative of this function y is equals to 2x plus 2, which is 2. And the gradient of that line that we found, it was 2. Comparing the two together, it is the same thing, okay? Comparing it, it is 2, 2, okay? And this shows that the act of differentiation basically came from the fact that we are trying to find a gradient of a line or the gradient of any curve, okay?